Good morning. Welcome you all to the video lecture on the topic rectifier. I am Dr.R.Vidhya, Assistant Professor of Physics, Vishayabar College. We will be exploring rectifiers and its key concepts. Rectifiers are nothing but the device which converts alternating quantity to the direct quantity. The alternating quantity may be current or voltage. So, the process of rectification can be done by means of using the rectifiers. These rectifiers can be made up of the materials, made up of metals and semiconductors like copper, aluminum or selenium, etc. The rectification process is nothing but which can convert the rectifier which converts the alternating current to the direct current. That process is called the rectification. Also, the rectifiers are used in the power applications which converts the alternating current to direct current in devices such as radio, battery, etc. Then why do we need rectifiers? Also the rectification process that is explained here. We know that every electronic devices such as amplifiers and also the battery need the DC power supply to operate, but we have alternating source where we can obtain the DC power supply. This can be done by using the rectifier along with the transformer. Initially the transformer performs the step down process, then which could be converted to the DC source by means of rectifiers. There are two types of rectifiers available. One is half wave rectifier, another one is full wave rectifier. Full wave rectifier is again classified into two categories like center tap full wave rectifier and full wave bridge rectifier. In the first case of half wave rectifier, we use the single diode in which the rectification process can be done. So, in this case, in the circuit, the transformer is connected with the diode, also it is connected to the output. So, this is the process of this is the circuit of doing the rectification by means of half wave rectifier. Initially, when the AC input source is applied to the transformer, this end becomes positive. I mean the diode D becomes forward biased during the positive half cycle of the AC input voltage. Also the current is flowing through the load resistance that can be observed through some device. So, the output of the half wave rectification is displayed by means of the waveforms represented here. During the positive half cycle of the AC input voltage only, the diode D conduct the current. During the negative half cycle of the AC input voltage, the diode becomes reverse bias, so that there is no current conduction takes place while the negative half cycle of the AC input voltage. So, only positive half cycle is observed as the output. During the negative half cycle there is no output, that is represented by means of the waveform here. This is the half wave rectification process. In the case of first type of full wave rectifier, that is center tap full wave rectifier, the circuit is shown here. In the half wave rectifier we utilized only one diode. Here instead of one diode, the center tap full wave rectifier needs two diodes named as D1 and D2. So, during the input of, that is during the first half cycle of the AC input voltage, in the end A becomes positive and end B becomes negative. So, that end A will, the positive end of the A will make the diode D1 forward bias, so that the current conduction takes place during the positive half cycle of the AC input voltage by means of the diode D1. So, during the negative half cycle, when the AC input supplies flows inside the circuit, the end B becomes negative, that makes the diode D2 positive, I mean D2 forward biased, D1 negative, the D1 becomes reverse bias, so that the current conduction takes place through the diode D2 while the negative half cycle of the AC input supply flows inside the circuit. That is also the another output by means of the negative half cycle of the AC input voltage. So, in this way alternatively the diodes D1 and D2 will conduct the current for both the half cycles. In this way the process executes, that can be represented by means of the waveform diagram represented here. Next one is the full wave bridge rectifier. So, in the case of center tap full wave rectifier, the the process of making the center tap is very difficult, so we go for the full wave bridge type rectifier. In this case, in this circuit, instead of 2 diodes, the circuit utilizes 4 diodes named as D1, D2, D3 and D4. So here the circuit operation is mentioned by means of this circuit diagram. Here, when the AC input supply is sent through the circuit, the end A becomes positive, that makes the diode D1 and D2 becomes forward biased, so that the current conduction will takes place by means of the diodes D1 and D2 when the AC input supply, when the positive half cycle of the AC input supply flows inside the circuit, so that the output waveform is represented here with the help of the diodes D1 and D2. During the negative half cycle of the AC input voltage, when it enters the circuit, the end A becomes negative and B becomes positive. This end, this B end will make the diodes D2 and D4 will make the positive, will make the diodes forward bias, so that the current conduction will takes place by means of another 2 diodes. So in this way, during the positive half cycle of the AC input voltage, the diodes D1 and D2 will conduct the current. During the negative half cycle of the AC input voltage, the diodes D3 and D4 will conduct the current. In this way, the process is executed. Finally, we got the output of the circuit operation like this, and this for the positive half cycle, the 2 diodes will conduct the current. For the negative half cycle, the another 2 diodes named D2 and D3 and D4 will conduct the current, that is cyclically executed in this waveform diagram. So this is finally we come to the comparison of these 3 rectifiers. First, in the half wave, full wave and bridge type circuit diagram of all the 3 type of rectifiers are shown here. The output waveform also. In the half wave rectifier, only one half will be conducting the current, so that only one diode will be in the process of conducting the current, so that the output will be like this. For the full wave center tap and bridge rectifiers, both the diodes, in the case of center tap circuit, 2 diodes will conduct the current, but in the case of bridge type rectifier, all the 4 diodes will be in the conduction of current during the positive as well as in the negative half cycle. So coming to the other particulars of all the 3 diodes, first one is the number of diodes. We require only 1 diode in the case of half wave rectifier, whereas we need 2 diodes in the case of center tap. Also we need 4 diodes in the case of bridge type rectifier. So there is no necessary of using the transformer in the case of half wave and bridge type rectifier, but it is necessary to utilize the transformer in the case of center tap rectifier. Then coming to the efficiency, it is very important. Efficiency is nothing but the ratio of the input to the output. I mean, how much DC is converted to the applied AC, that is the efficiency. In the case of half wave, it is only about 40.6%, whereas in all other 2 cases of the center tap and bridge type rectifiers, the efficiency is maximum about 81.2%. Coming to the ripple factor, it is higher in the case of half wave, it is 1.21. That is the fluctuations in the output of the DC. In the case of center tap and bridge type rectifier, it is only about 0.4, right? So it is better to use the center tap and bridge type rectifier rather than the half wave rectifier. Coming to the output frequency, it is equal to the input frequency in the case of half wave rectifier, whereas it is double the amount equal to the input frequency in the case of full wave rectifiers like center tap and bridge type. Then the last one, the peak inverse voltage, the maximum voltage, it is equal to the maximum voltage of the input supply in the case of half wave, whereas in the center tap and bridge type rectifier, it is also in the bridge type also it is equal, but in the case of center tap, it is double the time to the maximum voltage of the input voltage. I hope you understand well. Thank you.